Hey everyone, in this video we'll be discussing about the basic instruction execution cycle.
Instruction cycle, also known as the fetch decode execute cycle, or simply the fetch execute cycle, is the cycle that the central processing unit follows from boot up until the computer has shut down in order to process instructions. It is composed of four main stages: the fetch stage, the decode stage, the execute stage, and the write back stage. In the simpler CPUs, the instruction cycle is executed sequentially, each instruction being processed before the next one is started. In most modern CPUs, the instruction cycles are instead executed concurrently and often in parallel through an instruction pipeline. The next instruction starts being processed before the previous instruction has finished, which is possible because the cycle is broken up into separate steps.
Now, the first process of instruction execution cycle is the fetch process. As the name suggests, its primary purpose is to fetch the data from the memory. However, the process involves various stages. In actual terms, it refers to the process by which the CPU retrieves the instruction from the memory that it needs to execute. During the fetch process, the CPU sends a memory address to the memory controller to retrieve the instruction from the memory location where it is stored. The memory controller then retrieves the instruction from the memory and sends it back to the CPU for further processing. Once the instruction is fetched, it is temporarily stored in the buffer called as the instruction register or IR within the CPU. The instruction is then ready for the next step in the instruction execution cycle, that is the decode process. It involves use of various registers like the ABR, memory address register, PC, program counter, registers Y and Z to store the data.
In the context of computer processing, decode refers to the step in instruction execution cycle where the CPU central processing unit interprets an instruction that has been fetched from memory and determines what operation it specifies and what data is involved. The decode step is the second step in the instruction execution cycle, following the fetch step, and it precedes the execute step. During the decode step, the CPU determines the instructions opcode to determine what operation is to be performed. This may involve looking up the operation in a table or performing some other form of lookup. The CPU also determines what data is to be involved in the operation, such as the operand, memory address where the data is stored. Once the CPU has decoded the instruction, it proceeds to the execute step where it performs the specified operation on the specified data. The decode step is a critical part of instruction execution cycle as it allows the CPU to determine what operation to perform and what data to use, enabling it to carry out the intended computation.
Next, the execute process. It is the third step in the basic instruction performs the operation specified by the instruction. In the execute process, the CPU first fetches the operands that are required for the operation. The operands can be registers, memory locations, or immediate values. The location of the operands is determined during the decode process. Next, the CPU performs the operation specified by the instruction using the fetched operands. The operation is performed by the arithmetic logic unit, which is the ALU, which is a component of the CPU that performs arithmetic and logical operations. The ALU can perform a variety of operations such as addition, subtraction, multiplication, division, bitwise operations, and comparison operations. Finally, the result of the operation is stored in a register or a memory location, depending on the instruction. If the instruction was an arithmetic or logical operation, then the result is stored in a register. If the instruction was a store instruction, then the result is stored in a memory location. It is important to note that execute process can vary depending on the instruction that is being executed. For example, if the instruction is a branch instruction, Then the execute process may involve checking a condition and updating the program counter to jump to a different location in the program.
So now, the write-back process. The write-back process is the final stage of basic instruction execution cycle. It is the stage where the results of executed instructions are written back to the memory or register. During the write back stage, the CPU writes the results of executed instruction to destination register or memory location. If the instruction involves a calculation or operation, the write back stage will store the results of an operation. If the instruction involves a data transfer, the write back stage will move the data from a source to destination.
For the instruction execution cycle, there are the 4 steps that fetch, decode, decision, and execute. And we will take the example that the add R3 R1 and with the help of the example, we will understand that how it will work. In the first step, there is a PC out, MAR in, read, select for, add, and Z in. In that, there MAR the memory address register. In that the first step, the instruction operation is initiated. In that, data from the PC is sent to the MAR. And in the execution, PC always pointed towards the next instruction cycle. And after that, read request is sent to the memory, and after that there is a select signal is sent, and the constant 4 is taken. After that, the add instruction is happen, and that is stored in the Z in. And in the second stage, the Z out. In the second stage, the next operation is updated result from the second and is out, and after that is loaded in the PC. And after that is third stage. It is the MDR out, MAR in, MDR out, IR in. And in that in that first it is fetched out from the MDR, and after that it is the data is transferred in the IR in. IR means the instruction register. In these total 7 steps, the first, second, and third step, that is the instruction fetch phase, and that is the common for all instructions. And after that, from the step 4 to 7, that consists the instruction execution phase. The fourth step is the R3 out, MAR in, and read. This is to activate the control signal. And in this step, data is transferred from R3 to the MAR, and the memory read operation is initiated. And after that, in the stage 5, that is the R1 out, Y in, and WMFC. In that, here the content of R1 is transferred to Y for the addition operation. And now we get the 2 operands that contents of the R3 and R1. And in the 6th step, the MDR out, select Y, add Z in. In this step, the data from the MDR is out, and also from the Y, and the addition operation is taken on, and that is the stored in the Z. And in the 7th step, it is Z out, R1 in, and after that end. And in that, the data from the Z is transferred to register R1, and that is stored in the R1 register. After that, end execution is happen. And whenever we write the end statement, it will initiate the execution of the next statement. Thank you.